This video describes vapor pressure and the factors that affect vapor pressure. Vapor pressure is defined as the pressure exerted by gas which is in equilibrium with the solid or liquid phase in a closed system. To understand this concept better, consider a beaker containing water in the liquid phase. Water is maintained at atmospheric pressure. The beaker is covered with a glass lid such that there is no exchange of matter and hence creating a closed system. Water that is in the closed container is heated using an external heat source. When heat is supplied, water molecules start to evaporate when the temperature reaches 100 degrees Celsius, as the boiling point of water at atmospheric pressure is 100 degrees Celsius. Water molecules get converted into vapor. At this stage, the rate of evaporation increases. Since it is a closed container, vapor molecules are trapped above the liquid, and they start to collide with the walls and condense back into the liquid. At this point, the rate of condensation increases. When the rate of evaporation equals the rate of condensation, the system reaches equilibrium. At this stage, the vapor molecules exert a constant pressure on the liquid, which is called vapor pressure. Hence, vapor pressure is defined as the pressure exerted by gas which is in equilibrium with the liquid. The factors that affect vapor pressure are the types of molecules or the intermolecular forces and temperature. If the intermolecular forces are relatively strong, the vapor pressure is low, whereas if the intermolecular forces are relatively weak, then the vapor pressure increases. Example: the vapor pressure of ethanol at 25 degrees Celsius is 75 torr, whereas diethyl ether is 520 torr at 25 degrees Celsius. Diethyl ether has a relatively high vapor pressure due to weak dipole-dipole forces and London dispersion force. Whereas in ethanol, in addition to weak dipole-dipole and London dispersion forces, there is strong hydrogen bonding between the atoms, and this results in low vapor pressure. Hence, the vapor pressure of a compound is low if the intermolecular forces are relatively strong, and vapor pressure is high if the intermolecular forces are relatively weak. Another variable that affects vapor pressure is temperature. As the temperature increases, the rate of evaporation increases, and the number of water molecules in the gas phase also increases. As the rate of condensation increases, the number of molecules that start to condense back into the liquid phase also increases, hence the vapor pressure. Therefore, increase in temperature increases the vapor pressure. Similarly, when temperature decreases, water molecules prefer to remain in the liquid phase rather than the gas phase, hence the vapor pressure decreases.